In part 1 of the SSIS Data Transformation series, I noticed that the pipeline doesn't check for duplicate records in the CSV, causing multiple rows with the same order ID to be inserted into the sales order table whenever that order ID doesn't already exist. To give you a glimpse of how the issue occurs, let's run the package using a CSV file that contains duplicate records whose order ID values do not yet exist in the sales order table. As you can see, all duplicate rows in the CSV are inserted into the sales order table. This is because the pipeline has no logic to detect or filter duplicates, allowing every row to pass through as long as its order ID doesn't already exist in the target table. To fix the issue, we will introduce additional transformation components into the pipeline. The first step is to uniquely identify each record by assigning a row number. To do this, we add a script component to assign row numbering based on the sorted order of the records. We need to identify the most recent record for each order ID. We will use a sort transformation to order the incoming rows by order ID in ascending order and order date in descending order. In the script component, we add a new output column named RowID to store the row number assigned to each record. Ideally, a script component is used when you need custom code, and it requires basic programming knowledge to handle logic that other SSIS transformations cannot perform. In our case, we are using the script component only to create a simple row counter that assigns a row ID to each record. In the process input row method, we use a simple counter that increments for every row and assign that value to row ID, giving each record a unique sequential identifier based on the sorted order. Because the sort transformation has already ordered the rows by order ID in ascending and order date in descending, the script component can now generate a sequential row number for each record, ensuring that the most recent row for each order ID is marked as the first occurrence. Next, we need to identify which record is the primary record for each order ID group, specifically the record with the lowest row ID value, which represents the most recent entry after sorting. To accomplish this, we will need a merge join transformation. We start by adding a multicast component. Then we send one path to an aggregate transformation to group rows by order ID and capture the minimum row ID for each group. The other path goes directly to the merge join. Since merge join requires both inputs to be sorted, we add a sort transformation on each path before connecting them to the join. To ensure the merge join can correctly match rows, both sort components must use the exact same sort order. In this case, we configure each sort transformation to order the data by order ID and row ID both in ascending order. In the merge join, we set the first path as the left input and configure the join type as left outer join. This ensures that any rows from the aggregate path that don't match a row ID on the left side will produce null in the joined row ID column, making duplicate records easy to identify. Then we select the columns we want to output, including the row ID from the aggregate path, while excluding the row ID from the left path. Next, we add a conditional split to identify records with null row ID. Rows with a valid row ID continue through the main process flow. Any row where row ID is null is treated as a duplicate and routed to the exception table. Now let's test by removing the previously inserted duplicates and running the package again. As you can see, only one record is inserted into the sales order table, while all duplicate rows are correctly routed to the exception table. This confirms that the CSV duplicate record issue has been fully resolved. Thanks again for joining me, and if you found this helpful, don't forget to like and subscribe.